Again, thank you everybody for coming on this very early morning. I appreciate your time here. My name is Zohar Alon. I'm leading the cloud product line at Check Point. Just a few words about myself. So I started my career at Check Point in 1996, so that's almost 24 years ago. I've been there for the first 7 years when we just invented this thing called firewall and enjoyed to see this thing called internet picking up speed and being part of connecting networks to the internet and between applications. In 2011, we started a company called Dome9. Me and my co-founder Roy. We were dealing with public cloud security, and last year we got acquired by Check Point. And for me, it's like coming back home. Good to see a lot of familiar faces, people that were playing with firewalls in their early days. And I'm going to walk with you today on how do we take some of the challenges that we've seen in public cloud and how we bring technologies that enable us to solve problems and get the comfort and reassurance of our private data centers, if you will. So I won't go through a lot of the background side. Just to give you a hint that coming from a public cloud, we started with the public cloud even before they called it public cloud. I think they only came up with the term for infrastructure as a service in around 2013 or 12. But now seeing it from the Check Point perspective, we see that the public cloud is just one piece. There are many other pieces, and definitely for the large enterprises out there, it's not one journey. It's several paths that essentially lead to a mutual goal, to a place where we want to take different technologies that are shifting while we speak. Somebody's probably inventing the next cooler thing than serverless, and effectively getting them and allowing us to protect them in a way that you get the reassurance that whatever the dev team chooses from a technology perspective, on-prem, on the cloud, in a private or public setting, no matter which public cloud or private cloud technology we're talking about, and no matter which technology they're using, you have a security framework, a suite of solutions that gives you the peace of mind from a security leadership perspective. So you probably have seen that many times, but the reality is that as we choose different cloud technologies, and I'm mostly talking about platform as a service and infrastructure as a service, we give certain control back to the service provider, back to the cloud provider, who is taking what is under our responsibility, what is under their responsibility. But I won't be telling you any secret if I tell you that it's all our responsibility. It doesn't matter if who made the mess up. It's your responsibility as security leaders to deal with it. Even on SaaS applications where seemingly we have very little control, but we do. We control the users, we control many other things. Now, what happened when kind of public clouds started picking up end of 2016, I would say, this became an ocean. This became a thing. Every 6 weeks, I believe, we had a new cloud-related misconfiguration. It could have related to a database that somebody left an unpatched administrative interface without any network segmentation in front of it, or a storage bucket, God forbid, that was left out there, or just somebody just forgetting their credentials whether it is GitHub or whether it's embedded in an application that they have sent to a third party. And this helped our entire industry realize that this is real. The chances of getting hit are dramatic. And as Gartner said about this thing is that they started by saying that by 2022, 95% of the cloud breaches are going to be due to a misconfiguration. They have changed it last year, and now they claim that 99% of cloud misconfigurations of cloud breaches are going to be a result of a misconfiguration. It means that only 1%, the poor 1%, will be a result of a real targeted attack with all the the hacker stories that we see. The other 99 are going to be just something stupid that just happened. And we need to realize that this is something that's going with us every day. This problem just materializes and just grows as we use cloud more, as we diversify our cloud technology portfolio. Now, what do the bad guys want? Essentially, we have two main resources that they want to, two main type of assets. There's our data, when somebody can, encrypt and sell it back to us unencrypted. Somebody can destroy half of it and take a ransom for the other half. And somebody just steal it and sell it to the highest bidder, just shame us by putting it online. And the other type of assets are compute assets, servers, technologies that can be used to mine Bitcoin, launch another attacks, DDoS, a third party that's not even involved in the game. And essentially, we all know about the network attack surface. Checkpoint was built essentially protecting the network attack surface, but cloud technology and the modernization of this battlefield has also introduced the identity attack surface. Today, instead of hacking the network in a sophisticated way, I can social engineer one of the, let's say, the DevOps people and use their super user credentials to get complete access to the data resources. This is a new type of threat that we didn't have 10, 15 years ago. Or the user-related attacks had different impact. Today, your head of DevOps in your organizations, they are very lucrative targets. They own access to a lot of valuable data, sometimes without even understanding it. And the public cloud presented another new type of an attack vector that we don't have in our on-prem. In our on-prem, we have our storage area network is segmented. The management interfaces for most of our technology is in a very, very, very private, isolated network. In the public cloud, it's just sitting there on an API endpoint in Azure, and essentially anybody with an HTTPS capability can try and interact with our control plane, with the inner elements of our data center. And this is a new thing. And it only takes one of them to be put out of sight for a little while to get access to all our assets. Some of the threats that relate to them, but as you can probably understand, your job is getting more and more complicated in trying to deal with all those complexities. And now just imagine that we're talking about multi-vendor, multi-location, multi-cloud, multi-technologies. This problem gets complicated by exponentially just by being there. So at Checkpoint, we have a product of families called CloudGuard, and I go just quickly over them just to kind of get you up to speed before we get to the network log analysis part. But essentially, the CloudGuard product family has several different components dealing with network security. First, segmenting our vNETs and VPCs and the interactions between the corporate, the on-premise to the cloud, and from the public cloud to the public internet, from a network plumbing perspective and advanced threat prevention on the networking. Dealing with things that can reside in the network element, whether it's advanced threats, whether it's payloads, whether it's specific protocols that we can protect. And then what happens inside the vNet? Remember, the traditional network security gets us to the perimeter, gets us to the public cloud doors, but a misconfiguration on the vNet itself from not segmenting properly. Microsoft Azure's vNet virtual network security group, is a tremendous technology that you can today use to create segmentation that you could not have done so 5 years ago. And the reality is that we have the technology today that helps you to see it first and then deal with it and run with it quickly. From an identity perspective, I want to touch on one of the things that I highlighted. Imagine what can you do if you can give your head of DevOps a mobile application and tell him that before he wants to wipe the entire data of the organization that runs on the public cloud, he would have to add an additional level of authorization. I'm not talking about authentication, because remember, his identity was compromised. Somebody piggybacks his identity and now has his keys on reshuffling our encryption keys with the Azure Key Vault. And essentially, what if we could allow, or what if we could ask them to verify that they actually want to re-encrypt or delete or wipe this data before they do so? And we have technology that allows you to do that. It's an out-of-band mobile application that essentially protects the very, very undoable or dramatic or catastrophic activities that you can do with a simple API call if you're a super user. And that's for that. Now, when we talk about the security posture, you all know about the Azure Security Center and the capabilities there. We add a layer of continuous compliance and governance that essentially makes sure that all your blobs are well encrypted, well access controlled, well defined, that the IAM rules in your Active Directory fit what they need to be. And the idea is also to do it in a continuous way. It's not a one-time, I'm doing a daily scan. No, you're not doing a daily scan. You need to do continuous real-time analysis every time a change happens. This is not something like we use from the software vulnerability where you could allow ourselves to, run the Tenable scan every once a day. And the thing that I want to focus on today is the cloud network security analytics. So how do we take activities coming from the cloud, deal with the aspects of, okay, what can I learn about the stuff that's happening now? I'm going to buzz through this quickly and move to, I'm going to introduce you what we call CloudGuard logic. So CloudGuard logic is our attempt to essentially say that what we get from the logging capabilities in public cloud today is great, but it's practically useless. And logic is how the transformation of making this trove of data, network logs, audit events, and making something reasonable out of it. This is an Azure NSG log here on screen. It has seemingly a lot of data, but I cannot get anything out of it. I don't know the tags of the object that generated, for example, this event. Maybe it's a minuscule container in a dev environment that I shouldn't be worried about, but maybe it's a function running in our PCI environment. Those things do not come in the network fingerprint of that log. So how do we turn this into something more readable that I have? This is, again, it could be much nicer, as you'll see in a second, but here you already see a story. You see events, you see association to certain elements, you see tags of inherited objects. And the idea is that we take those very ugly, very almost impractical network security NSG logs and transform them into something we can actually generate insight and respond on. Wouldn't it be nicer to see how all your machines, all the microservices, all the VMs, all the platform services, a managed SQL database that is not under your control. It's a database as a service that you consume, but it is a member of a network mesh that's interacting. Today, with the current technologies, especially from the visualization, discovery, and investigation purposes, you have no capability there, even with great solutions like Azure Sentinel or your SIEM solution. Your SIEM solution is simply digesting logs and generating a lot of revenue for the SIEM company, but the reality to ask questions are like, show me network security, show me a function that's interacting with an external source that may be malicious. This is something your SIEM solution will not be able to tell you. So we need to create super logs, and the reality. Oops, I'll let you take. The reality of this super logs is the ability to relate the contextual data, mesh it with information from several things, and tag it with geographical information, asset type, the user if there was a user, the action, and essentially generate an intent. What was the purpose behind this element? And if it makes sense to worry about it, or like 99% of your logs, you should store them, you can throw them away. But the reality is that today you spend any amount of time, you don't know if you're looking at the important stuff or not. So what is CloudGuard logic? Essentially what we did is we realized that context was missing. I don't have geo information with this with this flow log. I don't have a lot of the tags, the intent, the application, the use cases with that. So how we take threat intel feeds and fuse them with the vNet flow logs and with some Azure, other Azure metadata that I have to know in the moment this log was created. If I'll try to do that 24 hours after the log has been created, this same IP address will already be used, several other microservices running different containers, different platform services, maybe a NAT gateway, something else. If you don't fuse that information, the minute this log is generated, you can throw the data away. It will never help you. And some of you are nodding. I know that you know we came with it. We had the first solution that actually analyzes VPC flow logs and Azure vNet logs in real time with our network segmentation log. But the reality, it was not as useful as we thought until we came up with logic. And after we've used all the data, matched it with data coming from Checkpoint's Threat Cloud, which is essentially our big data lake that has information about many threats known and unknown, we can then generate the insights that you can create action on. We can do the visualization, which is, I didn't realize how visualization is going to be critical in that sense, but it is. Just because our complete blindness will show you that stuff inside the application are not as what as you envision, just from the sense of these are platform services that you don't have any access or any visibility into. And then you don't have to analyze them within CloudGuard logic. You can forward them now as enriched actionable data to your SIEM and even recently to Azure Sentinel. Or you can essentially start workflow in the organization with any of the many integrations that we have to essentially start responding to those intrusion alerts. And let me show you just a little bit in action. We have some nice examples. But if we had the CloudGuard IaaS solution, our network active threat prevention technology, together with CloudGuard Dome9 that's doing the continuous compliance, the inventory of all that, essentially what logic is doing is completing the circle and essentially taking real-time data into account when we look at our posture. And this is how it looks in almost real life. We have our visualized map that shows us all the live traffic that happened in a specific region, in a specific vNet. You build your own custom query and essentially see the data. You can dive deep into the logs, but this is not really the use case. And essentially they run continuously, but you can also run them manually. Live questions and queries and essentially triggers on this data. And you can build it, I'll show you how. So for example, we have a language called GSL, for Governance Specification Language. It's a language that moves from our compliance solution and cloud security posture management solution, Dome9, also to logic. And essentially it allows us to ask questions like, vNet flow logs, show me where all my vNet flow logs that are interacting with a malicious source, a malicious destination. And a malicious destination is a property coming from the threat cloud. And I can see here just the elements of my microservice, my application, that are actually doing so. So we can first reduce maybe a network of 1,000 players to just the 12 that are relevant for further investigation. Now this could be a scanning, this could be a scanner, it could be many things that relate to it, but essentially we got rid of the other 99 irrelevant logs for this specific query. We can even make it a bit more interesting. Show me all the actions where we actually accepted traffic from a malicious, in this case, source. And this is dramatic. This is essentially seeing it in real time, the last 60 minutes, the last 15 minutes, the last 3 months. We have an option to keep data in Logic for up to a year. So it's not designed to replace you, it's designed to give you that layer, but the ability to run any type of query. And the next one is something I like, because serverless, seeing your serverless traffic is impossible today. Reasoning about your serverless traffic is impossible. Same goes for any type of the container related in the public cloud. And what I can say, show me all the assets type of an Azure serverless function and how it relates to this information. And I can see the amount of the components that are interacting with this function in real time, internal assets and external assets. Now, in the VNet, in the log itself, what's here is a 10 dot something address. There's nothing in the logs that I showed you earlier that shows that this is a function. The minute this log was created, we matched it with our asset database for that specific Azure subscription, and we built that enriched log saying it's a function, these are its tags, and now you can interact and you can continue and build those queries. And it's not just designed for live deep investigation. The reality is that you can say a trigger saying, anytime this query happens, and let's say the tag equals PCI, generate an alert, start a workflow, start an automatic remediation if you know how to respond to that if it's that bad. The reality is you can write any number of those custom rules. They sit in the heart of the solution, in the engine, and every time a new event will trigger based on this. An enriched log will say that this is happening. We will let you know, and we'll let you start the remediation workflow. So the idea is that once we understand our attack surface, we can start dealing with the protection. And as I said, our CloudGuard family of products can help you that. And with the introduction of Logic, we don't just deal with what's coming in and with the static data and the posture data. We also deal with what's in the cloud, what's trying to come out of the cloud. And essentially, this may be a good opportunity to say that this is available on Azure today. We have support, obviously, for other clouds, as you can understand. But the reality is this supports AWS and Azure today. Flow log data, audit data, fusing it all together and generating insights. And I would ask you to go and see it live. We have some of the developers here in the conference with us. Come see it live. Tackle us with questions on how it can show you specific, for example, traffic that's generated from MySQL that's going to sources outside of a specific VNet, or any type of those challenges, and see how the products fare. And if you have maybe if we have a couple of minutes for questions, I'll be happy to take them. Yeah. Yes. So the question is, can we fuse together smart events with it? The reality is yes, of course. You can correlate that with smart events, but it's going to take time until we also ingest the logs from other checkpoint products into Logic. But the reality is yes. No, the Logic is the master for investigation and for dealing with that. Yes. So the question is, what sources can we ingest? So Logic was designed to ingest the ugly sources that coming from the cloud vendors. So flow logs, audit events. In Azure, there's actually a series of logs that are interesting that we will ingest and model, but there's no point in process data to be ingested into Logic. Logic is designed to be the processor, and it's designed to essentially take the load off your Splunk or whatever you use for SIEM, because our claim is that they don't provide meaningful value because they don't have the posture data that gives you those insights. Hope that answers the question. Thank you very much, and I'm available here if anybody has any questions. Thank you very much.